I'm basically a young space entrepreneur. Richard David was talking about how a lot of the new space movement is led by the young guys, so I guess I'm one of those. This is my second space company I've started. The first was a company called Earthrise Space, based out of Florida, and we were the first student-led team competing in the Eagle X Prize. So this is my second. It's really exciting. I'm going to just jump right into it. So kind of the basis of my talk and what we've been doing for the past 3 years comes down to this idea that very soon there'll be a much more affordable way to get your hardware into space. Thanks, Richard. So how? Well, it's easy, and that's by building it there. So actually, by this time next year, an email will be sent to the space station. And on that email will be the instructions for a 3D printing robot that Made in Space is building to build the first piece of hardware ever built off the planet. And that's kind of the overview of the talk, is that what we've been doing for the past 3 years is building 3D printing systems for microgravity, basically to enable space-based manufacturing. So this is a technology we've been doing a lot of work on. It's high technology readiness. This time next year, that first printer will be on the space station. It's capable of doing about 30% of the spare parts. And I can go into that estimate there in a little bit. And this is just the beginning. Made in Space has been working on the next steps and really growing the technology from each step forward. It's about finding the actionable first step and moving towards, the big vision. So a little bit about the company. We were founded in 2010. We're based right down the road at the NASA Ames Research Park. We've got around 20 to 25 people working in the company in some facility, about 12 engineers at a full time, and very large R&D focus. It's about building those next steps, those next technologies. I like this quote I have up here from our CEO, Aaron, who unfortunately couldn't be here today. The future of space exploration will change forever when everything we need for space is built in space. In this future, parts, habitats, and structures are not launched and assembled, but instead 3D printed layer by layer in space with added manufacturing. I think that really kind of tells a really good story. Oops. So in case you guys don't know about 3D printing, actually show of hands, I'm sure everybody knows about 3D printing here. Yeah? Okay, enough, right? Obvious thing is additive manufacturing. You're building a part up layer upon layer, unlike traditional manufacturing, which is subtractive, where you have material waste and you're carving away your next shape. So really cool technology. It's very autonomous. Low material waste, things like that, make it perfect candidate for space applications. So a little bit about how did we get started, why are we doing what we're doing. In 2010, I was speaking at the Space Manufacturing Conference, also right down the road at NASA Ames, where we were announcing the company and laying out our vision for what we would be doing to get started. We laid out 3 initial goals. The first one was we're going to study the effects of microgravity on 3D printing. The next one is we're going to adapt 3D printing technology so that it would be useful in space. And then the third is fly a 3D printer to the space station to demonstrate the usefulness of manufacturing there. So in 2011, we were awarded a NASA contract through the Flight Opportunities Program, where we flew dozens of different 3D printing technology and really learned about what it would take to make this technology work in microgravity. And I'll go into that in a second. The second, adapt the current state of the art. This started in 2012 with a NASA contract to design a 3D printer for space station based off of all those lessons learned in our microgravity research. And now today, we're working towards that last goal of flying the printer to station, and we'll be there next year, and then there'll be a few technologies coming down the road after that. So I want to talk about, what is the technology we're using and why are we using it. We started with extrusion-based 3D printing. A lot of people know it as fused deposition modeling, FDM. It's the very common desktop 3D printers that we all are seeing around the press and everything. The idea of why we started with this, we did a pretty extensive trade study, and focus your attention on the right side of the screen, this chart. It really comes down to this. We looked at all these different technologies. We realized that with this extrusion base, it really is the best candidate for meeting all the requirements for ISS, which was a huge design driver. It's a solid feedstock, so you don't have to mess around with a powder or some sort of liquid. It makes it easier to control. There's a lot of terrestrial development. This is the technology that has been being developed terrestrially, so we can leverage that. producing mission critical parts. This was an estimate that actually NASA worked with us to come up with. They looked at all the things that are broken on the space station today and realized about 30% of that were perfect candidates for a plastic printing technology. And it really comes down to lowest risk. What was the way to get manufacturing in space the quickest? This is what we identified as that route. So to start with, we did these microgravity research flights, and I think this chart kind of sums up really the idea there. We've done 4 flight weeks. Most of them were in 2011, and then we did one this past summer where we verified the actual prototype technology for station. I'll show you that in a second. We've tested the printers in 0, lunar, Martian, and also, it's not even on here, but the 2G pullout. So when you're in these airplanes, you're getting microgravity and then hypergravity. So we've tested the printers across that whole range and accumulate over 500 parabolas. That equates to a little over 3 hours of total microgravity time. And if you look at the cost figure to do these flights and what NASA's put forward, that's a little over $1 million in cost. So jumping into the details on this research, we tested a lot of commercial printers. In the beginning, we thought we would just take a commercial 3D printer, make some small modifications, put it on the space station, and call it a day. You know, get the printer there, do manufacturing. What we realized is we started testing all these 3D printers, none of them actually worked in microgravity. Every single one needed modifications, and most of them were heavy modifications. And even if all of those worked, just to design a printer to put on the space station, you have to replace almost every material to meet the NASA requirements for materials and safety and things like that. So we ended up designing a printer from the ground up based off of these lessons, because what we did was we tested all these printers and we kept modifying them until they worked, and we found out what it took to make the printer work. What it came down to, the graph here, kind of my sciencey graph, but we're looking at the pre-modified printer, which is a sloping line, compared to a modified printer based off of the resolution of a part. So we were looking in this particular instance, layer resolution, and really the goal was to modify these printers until you could get a printer to work in microgravity or hypergravity just as well as it did on the ground. And that's what we're demonstrating in this chart. So in the end, what we ended up with was the idea and the science behind designing a printer that wasn't just for microgravity, but really for any gravity. So we call it gravity-independent printers. And we took our latest prototype of this technology, and actually very similar to the flight unit that will fly next year, and we took it on microgravity last year. So this is me. There's the device there. And we verified that all those design changes that we made into this design worked. Everything worked fine. So let's talk about this printer that's going to the station. We call it right now under the Additive Manufacturing Facility, or the AMF, and it's divided into 2 missions. The first mission is a technology demonstration mission. It will fly next year, and this is with partnership with NASA, mostly NASA Marshall and NASA Ames as well. And it's called the 3D Printing in 0G Experiment, or 3D Print. Maybe not the best name, but it's I think the nice NASA style naming. So we're flying this as a technology demonstration because we've done all these tests on the ground. We've done tests in microgravity research flights, but the most microgravity time we've ever had 3D printing is for about 20 seconds at a time. So the question is, what happens when you expose a 3D printer to the long-term effects of microgravity? So that's, first and foremost, let's learn that before we send the actual manufacturing facility to the space station that is going to be producing the mission critical parts and things like that. This is a place for us and for NASA and for anybody really to start understanding what it takes to do manufacturing in space. And that launches next year on SpaceX 5, and we're right now building the flight hardware in our lab. And the whole point of this is so that we can learn from this experiment so that we can do the second one, which is the AMF 1.0 mission. And that will be on Space Station 2015. The goal is that that's a permanent manufacturing facility for Space Station. So that it's something that not just the NASA or even other space agencies can use, but anybody. All of you guys in the crowd will have access to use this facility, and I'll talk about that a lot in a second. So let's go into the benefits of having a 3D printer on the space station. What I've done is I've broken it down into 2 areas: ISS Crew Utilization and Commercial Utilization. So along the lines of crew utilization, we've seen kind of 3 key areas. The first one, reducing manifested spare parts. And you'll see why that's important in a second if you can't imagine already. The second is making tools and hardware, kind of one of the obvious ones. An astronaut needs a tool that doesn't exist on station. Let's just build it there. And then the third is emergency scenarios, kind of the holy grail of why you would want this. And if we imagine the ISS is a test bed for future human mission well beyond LEO, this is a great place to start learning about how to manufacture in space before we go to Mars, and absolutely need a 3D printer to make that safe enough for humans to go. And then on the commercial end, we see three areas as well. Fundamental research is kind of the cornerstone. It's the idea of using this facility on station to understand about designing for microgravity. What happens when you remove the launch requirements and can design structures that only need to survive in zero gravity? We can use this facility to test that. The next is actually 3D printing experiments and experiment upgrades for station and for the researchers. And the last is, you'll see it's more than CubeSats, but I think this is a really good way to tie it together. The idea of actually manufacturing CubeSats, small spacecraft, complex systems on the space station and launching it from that platform. So crew utilization, I think this is a really good picture to explain it. This is Don Pettit on station surrounded by the cargo transfer bag. So I'm sure these are filled with lots of different things, but I like to imagine how much of this is filled with spare parts and things like that. And the fact is there's over $1 billion worth of spare parts manifested for the space station, and the reason is because it has to be. You know, we don't know what might break while the crew is up there, so we need to have the redundancy and the spare parts just in case something breaks, and it takes up a lot of space. The ISS has, you know, so much volume that is occupied by things that will never even get taken out of the bag, but they just have to be there just in case. So imagine if you had way less of these bags, you just had a few bags filled with the raw material, and then you manufactured whatever you needed once you needed it. The next is tools and hardware. This is, some of you may recognize this last year. I think it was last year, Sunita Williams was on station, and she was fixing a power system on a spacewalk, and there was an issue, and she needed a tool that didn't exist. And she fabricated a tool using her toothbrush, some tape, and looks like some sort of metal fitting. So she was able to fix the power system, and it was a critical fix. Luckily, this toothbrush worked. What happens when the toothbrush doesn't work? We'll have a 3D printer there, and we can print the tool that's needed. And actually, the ground can design the tool and send that up, so it doesn't take up crew time. And the last is emergency hardware and emergency scenarios. This is an interesting story. There was back during shuttle, there was a satellite that was being launched out of the payload bay of shuttle. It gets, the Canadarm puts it out, launches it, and it doesn't turn on for some reason. And what they do is they grab the satellite, they bring it back into the payload bay, and I don't know the details of the story of why the satellite had it, but somehow, for some reason, it actually had a switch of some sort to reboot the satellite. So astronauts designed this tool up here on the end of the arm, which was made out of paper and duct tape, and maybe a piece of string, to reach out and flip that switch. And the reason it was made out of paper and duct tape is because they didn't want to damage the satellite. So they flipped the switch, and under the right amount of force, that paper would just rip apart and it would break before the satellite did. So we designed, we did this big feasibility study with NASA looking at all the things that this could be used for, and this is just one example of where you could 3D print the exact tool that you need to flip that switch, and it would break exactly under the right force and not just maybe break because you duct taped it together. And then maybe the most iconic space emergency scenario was Apollo 13. And we like to think that if there's a 3D printer on board, that it may have been, Houston, we have a solution. And we, specifically for the air filter, the square filter, or the round hole problem. So we threw this problem at an intern about a year ago. In under an hour, he designed a solution to manufacture an interface between the square filter and the round hole. And by the end of the day, we had it printed, hooked up to some NASA hosing and functional. So just an idea of how you could drastically reduce that risk and really get the crew the things they need in a moment's notice rather than scrambling to figure out how to fix it with whatever you have there. On the commercial end, this is something that really excites me, is the research end of it. And I think going back to Richard David again, I think he was spot on when he said made in space in the microgravity research category. This is going to be huge. The idea is that one day we want to build everything we need in space. And that we can design new mission architecture around the idea that we don't have to launch everything from the surface of the planet anymore. We don't have to design our structures to survive launch and the launch loads incorporated with it. So the idea is using our platform starting next year to actually look at the fundamental research that you can do on structures that are made for zero gravity. So a structure that might not even survive its own weight here on Earth, but would be perfect in space. So it's about using resources appropriately and being conservative with them. And then next is experiment upgrades. And this is an obvious reason for why space station needs a 3D printer. And the way we look at it is, if you look at every, space station is a laboratory. And it's a national lab in the US. If you look at any other national lab on Earth, the way it works so well is that a scientist is able to iterate quickly. A scientist is able to design an experiment, run the experiment. If something doesn't work, make a little change and then run it again and get to the result they need as quickly as possible. That's not something that can happen on space station today. The scientists aren't even there to begin with, and then when something doesn't work, they have to wait for months or years to get the next piece of hardware launched. So what if you could actually just repair the experiment, make a change to the experiment on the fly, without even the scientists needing to be there? That will enable the national lab to become much more useful and more like what a national lab is on Earth. On top of that, we can 3D print entire experiments. This is actually a 3D print experiment on station. It wasn't printed there, obviously, but just an example that you could print experiments there. And in the beginning, you might not print everything. You might just print the structure. But what if you had electronics that were already there in an experiment that wasn't being used anymore, and you had other pieces of other experiments, and you could actually build a new experiment in space without ever having to launch anything? That might open the door for a new researcher or a new research group to get into space that hasn't been able to be there yet. And the last one is the CubeSat production. It's kind of a really nice milestone to be looking forward towards. The idea that maybe in the beginning, just like the experiments, we launch the electronics and we launch the sensors and things like that. But just being able to build the structure in space and assemble that there can change the game. We can get things into space quicker. We can get the satellites where they need to be much faster than we've been doing before, and much more customized. We don't have to constrain ourselves to building a satellite to fit inside of a launch fairing or inside of a Peapod launcher even. We can design satellites to be the shape and size they need to be for whatever that mission is. So now I'm going to tie that all together. Oh, that's a bummer. Okay, that says opening new space-based markets. And that's really the idea. The idea is emailing your hardware to space. I mentioned it earlier. This will happen next year. And the year after that, 2015, we'll have a facility open for everybody to use. It's a service-based business model. If you want to use it, you can basically email that hardware to space. You'll get your hardware there quicker. And we see it as a disruptive tool for the space entrepreneur. So focus your attention down here. Right now, we're actually accepting unsolicited proposals for what the first prints will be. We have a number of groups coming to us trying to get in the queue, get in the line for those first prints. So if this is something you're even mildly interested in, write down my email at the last slide. Get in touch with me, because now's the time to start talking to us, because it's going to help inform some of our design decisions even for what this facility is capable of. And on the government end, that also got a little screwed up. Enabling space agencies around the world is what it says. The AMF was designed as a tool for all the space agencies to use. So it's not just NASA's tool. It's for everybody. And for two things: planning ISS missions more effectively, designing things where you don't need to bring every spare with you, and then also using this technology on ISS as a test bed for those future human missions elsewhere. And the thing that I'm really excited about is the idea that countries around the world who haven't been able to be in space yet, or maybe just don't have a big presence in space, may be able to use this technology to get into space. And more so, get on this ISS. A country that hasn't been able to afford that will now be able to afford it by having an experiment or a payload printed in space. So if there's one slide to leave you with, one slide for you guys to remember, it's this one, that this is happening now. Manufacturing in space is happening, and there's a way for you to get involved with it. Right now, we're accepting unsolicited proposals for the first prints. Next year, we'll have the first parts built in space using on the 3D print project, and also a formal call for proposals will happen around that time. By 2015, your hardware will be built in space, and we'll be continually advancing that technology, and moving on beyond that, we'll be rolling out future versions of this technology, much more capable, doing more and more things, making it more easier to get everything you need in space. So just in closing, a few key takeaways. The first 3D printer will be in space next year. The platform will be available to you and to everybody else to use. That's really exciting. The first technology is capable of doing a lot of stuff. 30% of the spare parts is a good estimate, and it really shows you the capability. And the last thing, most important, is I really want to hear from you guys. Now is the time. If you have ideas of what you want to print, let's talk, because that will inform a lot of decisions we're making. And we want to make this as useful to everybody as possible. That's the whole point of it. All right, thank you.
Okay.
My email is jason@madeinspace.us. It should have been on the last slide.
Alvaro, San Jose State, an SM contract. In particular, what's the largest thing that the flight hardware can build, and more generally, where can you find out what the limitations are?
Yeah.
And the second part of the question, is there anything you discovered that you think you can make in micro G that you couldn't make on the ground?
That's a good one. Okay, so two questions. I'll go into both. The first one is, what's the size limitations on the first printer? All of this isn't 100% public yet. It's partly why we're accepting unsolicited proposals, so we can start having these conversations. But what is public is that we've designed this printer to be able, basically with the requirement that it has to be able to build a full CubeSat size volume. So imagine if something can fit into a 10 centimeter cube, this printer would be able to build with it. The second question is on the idea of printing things in space that you bring back to the ground. And I didn't talk about that, but it actually is a really interesting area because the whole idea of space and making money in space is that you're benefiting people on Earth. So if you can actually build things in space that couldn't have been built on Earth and bring it back, that'd be fantastic. So we have a couple ideas, and we actually have had people come to us with their ideas, and I think one of the more interesting ones that we can't talk too much about, but what I can say what it is, the area the industry is involved in is fuel cells. There's somebody a group that came to us with an idea for a new fuel cell technology that they believe could only be manufactured in the absence of gravity, but brought back to Earth would increase efficiency of a fuel cell. So we think there may be some very high-tech sectors on the ground that could benefit from this.
Dan Barstow, Virtual High School. I'm curious about the frontier of what you can and cannot manufacture. You showed CubeSat, and then you had solar panels. I assume you can't do those electronics. The non-experiment you showed seemed to show some, some iodes or something in there. What can you not manufacture, and how is that frontier changing?
Yeah, that's a very interesting one. We usually look at it through the lens of what can you not manufacture today, and how's that changing? In 2010, when we started this company, the idea of even 3D printing in space wasn't a huge idea at all. And we recognized where 3D printing was headed, and we said, in a couple of years, this technology will be ready for space. So we started working on it. So now we're looking at what are those next technologies that aren't ready yet, and how is that increasing the capability of this system? So you're right, electronics aren't ready yet, and printing solar panels very early on. But those are technologies that are coming down the road. There's other groups working on those. And our goal has always been to adapt the technology for space. So what we're always looking at is how do we keep phasing that in. So today maybe you build the structure of the CubeSat, but one day you build the whole CubeSat.
Larry LaForge with the right stuff in Tahoe.
Oh.
I don't need a microphone. To Richard David's talk. How were you invested, and what are the investors, how are you invested in?
Okay, yeah.
And how is it that the investors expect their return on investment with respect to an exit strategy? Can you tell us about those things?
Yeah, this is actually an easy answer. Maybe unlike a lot of Silicon Valley startups, we haven't raised any investment yet. The mindset we had is that it would always be better if you could go straight to the customer. If the customer is ready to pay for something, go to them first. So our customer is NASA, and we went to NASA from the beginning, and so far we've funded the entire company also off of NASA contracts.
Yeah, apropos to the earlier question about what you can't make. I'm now seeing this proposed research going on in Europe for making metal parts. What's your view of that, and where are you looking in that direction?
Yeah. Okay. So what about, this first printer will print with a variety of aerospace grade polymers. What about other materials, right?
And particular metal parts.
Right? Okay. So what I was explaining before is we tried to lay out these actionable steps. How do we get manufacturing space quickest? And we identified that this polymer-based, extrusion-based printing was the quickest way. If we had to design a way to control a powdered bed of metal, that might take a lot of years in development. If we had to design a new type of metal printing, that might take a lot of years in development. So we went with this as the first step, never trying to imply that you would never want to print metal parts in space. One of the end goals is obvious, that you would want to use resources in space one day. You don't want to have to always be dependent on launching your resource. So it's likely that there's probably a lot more metallic resources in space than there are plastic. So metal's been on the horizon, and there's a lot of really interesting technologies coming down the road that other groups have been working on that can enable metal printing. We've actually been demonstrating ways to do metal printing very soon, leveraging this technology we're developing for station, making modifications, and in the lab we're actually working on some ways to do metal now. So it will happen, but it's not a next year thing.
So I have another question. I think you alluded to using the orbital debris as a stock for raw materials, right, for your 3D printing. So I think you have that in your strategy. My other question was, can you do coatings?
Coatings.
So it's 3D printing,
Yeah.
but can you do coatings?
Yeah, wonderful point. So basically you build a plastic part coated in metal or coated in something different so it doesn't off-gas or things like that. You can. I mean, that's the short answer is of course. I mean, there's definitely a few different coating technologies that don't rely on gravity, and those are the ones we're investigating.
My name is Sunny Allen with One Star, and my question is, how much has your company benefited from the open source culture surrounding 3D printing?
Awesome question. So you know how, like, when I showed the chart of why did we go with this type of printing, and we said lots of terrestrial development is happening. And a huge part of that terrestrial development in the extrusion-based printing is the open source community. Patents expired on this type of printing in 2009, 2010 timeframe, and that's why almost every week there's a new Kickstarter for FDM style 3D printing. We benefited a great deal from that. That's why we were able to test dozens and dozens of 3D printers, and a lot of those even in microgravity. So we were able to look at all the different printers out there, understand what worked and what didn't, and leverage that and build a printer that perfectly suited for ISS.
Okay, one more question maybe.
We got it right here.
Couple more questions.
Darrell Burnett again, Capital Closure International Experience Technologies. Focusing on the philosophic element first is always my premise. What is Made in Space doing, or do you have any plans to do to give back to the planet in regards to the expansion of this technology?
Okay, that's a pretty cool question to close on. What are we doing to give back to the planet? How is this technology being developed for space benefiting people on Earth, right? And okay, I could give a whole talk on this. my passion is about how going to space is the ultimate way to benefit humanity. If we have to learn to live in space and learn to be 100% self-sufficient, we have to, recycle our own waste, make our own water, grow our own food, collect our own energy. At the end of the day, at the end of a very long day, when we're living in space, I think we're going to have solved a huge deal of humanity's grand challenges on Earth. The core value system at Made in Space is built around that. That what we're doing now is enabling those steps to happen, that one day we've really, really helped transform humanity and be a key player in that. But how is today's technology helping transform the lives on Earth? A lot of it's going to be how we infuse this technology back into the terrestrial 3D printing markets. So we've developed technology for space that, we had completely different design requirements than anybody else designing printers. Nobody else was designing 3D printers to survive a launch into space or to work on the space station in one of the most, extremely conditioned environments humans live in. So we have different design requirements, and that transitioned into different technologies that we had to come up with. So now what we're doing is infusing that back into commercial markets and land-based markets. So I think it won't be too long until we start seeing that happen, and it's kind of the typical space spin-off story. Thank you. Thank you.